Hello and a very good afternoon to all of you. Ladies and gentlemen, honorable speakers, allow me to extend a very warm welcome to this international webinar on the subject of smart meter implementation, challenges and opportunities. This international webinar is hosted by the Indonesian Smart Grid Initiative, or PJCI in Indonesian, and PT PLN Persero, and it is sponsored by VSD Automation, SDN Berhad Malaysia. It is also supported by the Global Smart Energy Federation, GSEF, and the Indonesian Smart Energy Society, MECI. My name is Adityani Putri, and together with my colleague, Muhammad Reza, we are both from the Indonesian Smart Energy Society, will be your moderators for today's webinar. Now, we have an impressive lineup of speakers. We have a total of 5 speakers who will be delivering the international, the Indonesian, the Korean, the Malaysian, and Indian perspective on the subject. So we have a lot to go through in the next 2 hours. Without further ado, I would like to welcome Mr. Edi Widiono, founder of the Indonesian Smart Grid Initiative, to deliver his opening statement.
Thank you, Ditri. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, Excellencies, ladies and gentlemen. First of all, allow me to express my gratitude to each and every one of you for being here with us today. We are very pleased to be able to welcome you on our important discussion today, Smart Meter Implementation Opportunities and Challenges webinar. This webinar is hosted by Prakarsa Jaringan Cerdas Indonesia, or Indonesian Smart Grid Initiative, together with PLN, and sponsored by VSD Automation SDN Berhad, and also supported by Global Smart Energy Federation and Indonesian Smart Energy Society. I would like to introduce our respectable speakers today. Number one is the keynote speaker will be Pak Bob Saril, the Director of Commerce and Customer Service of PT PLN Persero.
Thank you.
And then,
very good day, everybody. Nice to meet you, everybody.
Pak Bob, thank you very much, Pak Bob. And then Mr. Ignatius, Director for Electricity and Wholesale Business PT Indonesia Comnet Plus, subsidiary of PT PLN Persero. Pak Yoko.
Okay, thank you very much, sir, everybody.
Dr. Zainal Arifin. Thank you. Dr. Zainal Arifin.
Yeah,
lecturer at
good afternoon. Good afternoon, everyone.
And from our neighbor country who has implemented EMI, let me introduce Professor Dato Mohandas S. Nair from MCubes Consultancy, Sendirian Berhad, Malaysia.
Hello, everyone. Good afternoon. Very nice to be with you all.
Yeah. We are lucky to have also Mr. Peter Jung, Managing Director of Tide Limited Korea.
Hello, hello. My name is Peter. Nice to meet you, sir.
And last but not least, we have Honorable Reggie Kumar Pillai, the Chairman of Global Smart Energy Federation and President of India Smart Grid Forum.
Greetings from India. Thank you very much for having me. Look forward to a very fruitful discussion. Thank you.
Thank you. And also, our moderators are Dr. Muhammad Reza, the Indonesian Smart Energy Society, and Adityani Putri from Indonesian Smart Energy Society as well. Well, the purpose of our webinar today is mainly to understand the challenges and opportunities in smart meter implementation program from the perspective of PT PLN Persero, developers, and utility in other countries. And we like to take those challenges and opportunity as our best practice and lesson learned to continue with smart meter implementation in Indonesia. As you might know, PLN with 74 million customers has still a lot to chase to be able to implement, significantly implement advanced meter infrastructure. Although it has been also universally known and accepted that the rollout of smart meters is a key in achieving a lower carbon economy through smart grid, and advanced meter infrastructure is the entry point for the smart grid and technological energy transformation, as well as the entry point for increasing customer participation. We are so glad that you all here this afternoon. We appreciate your presence at workday time. Hopefully, our today's public discussion will enhance our understanding, and of course, we will be able to improve our practices in the future in the implementation of advanced meter infrastructure. So that is all from me. Good afternoon, and thank you. Enjoy our webinar today. Warm greetings, Smart Grid Indonesia. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you very much, Pak Edi, for the concise and yet very comprehensive introduction to the subject and also introduction to all of the speakers today. Just for your information, we already have 83 attendees at this webinar, so it's looking like we're gonna be looking at a very lively discussion, I think, at the end of the panel today. I would like to now welcome Pak Bob Saril, the Director of Commerce and Customer Management at PT PLN Persero. Pak Bob, please, if we could maybe have you to deliver your keynote speech.
Yes.
The microphone is yours.
Thank you very much. Bismillahirrahmanirrahim. To Honorable Pak Edi Widiono as a founder of Prakasa Jaringan Cerdas Indonesia. To Honorable Pak Ignatius Rendroyoko, Directors of Electricity and Wholesale Business PT Icon. And all the I think Pak Zainal too is with us together. And then to respectable Mr. Saurabh Kumar as the Executive Vice Chairperson of Energy Efficiency Service Limited Group. Mr. Aging Professors Datuk Muhandas S. Nair, M-Cubed Consultancy SDN Bihar, I think from Malaysia. And Mr. Reggie Kumar Pillai, Chairman of Global Smart Energy Federation or GSEF, and President of India Smart Grid Forum or GSF. Thank you, Pak Reggie Kumar. And my respectable Mr. Frederick Pontan, Chairman of Project, Chief of Representative EDF Indonesia. And to all the participants, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon.
Waalaikumsalam.
Have a great day. First of all, let's pray and thanks to our God who has been giving us some mercies and blessing so we can attend and gather here virtually in good condition in this webinar titled Smart Meter Implementation, Challenges and Opportunities. Ladies and gentlemen, PLN as a utility company with the largest asset in Southeast Asia needs a special business strategy to deliver service for to approximately 80 million customers spreading all over Indonesia. Our company generates more than 230 billion rupiah annually, so it must be a focal point to our concerns and priority to make sure that every installed meter in each customer is standardized, verified, and validated properly. Some metering technology and infrastructures have been developed rapidly, and some of them have been implemented to achieve a better and more accurate transaction. For example, automatic meter reading or EMR and prepaid electronic meters. However, those technologies are not enough to overcome the future challenges because the needs of energy grows variously, such as conventional needs, EV, electric vehicle, and PV rooftop. So it is important to choose bidirectional meters to monitor the flows of energy at real time. Some efforts to overcome the challenges and survive in the future, in addition to enhance customer experience, has been developed by PLN since 2018. In some locations, such as in Batam, East Java, Jakarta, and Bali, and for about 5,272 meters already installed. Advanced technology that have been tested and carried out are, we use the low power wide area network or LP1s, special long range ones is LoRa, we call it LoRa, and power line carrier as the communicator, and the fiber optic and cellular with international standard DLMS or device language message specification, standard by the IEC, you still remember 62056. The results of those trials conclude that PLN will start the AMI roadmap implementation or two-way meters on 2021 with the initial target of 150,000 customers, and then will rise gradually according to the needs and proposed roadmap. There are various advantages of EMI implementation. From the customer side, of course, they will get a more transparent and accurate billing. Also, it is easy for them to monitor anywhere and anytime. It is also more convenient for customers since they have more privacy rather than the conventional reading of meters, which has the monthly reporting procedure. For the prepaid customers, it will gain the customer experience since they did not have to input the token manually. For PLN side, EMI implementation will create the great success on the losses reduction that leads to our company efficiency. Demand side management process, since the demands of PV rooftop rise significantly these days. Real-time data of energy demand and supply is fulfilled accurately for tariff management of EV charging. Other benefits are the enhancements of measuring accuracy, which bring the customer trust and increase customer experience. Moreover, the EMI development are promising to implement smart grid and new potential beyond kilowatt-hour business for PLN. Ladies and gentlemen, seminar participants, besides those abundant benefits of EMI, it is important for us to keep it in our mind that the implementation of EMI is not as easy as turning our palm. Some factors that have to be well considered are, for example, investment costs, technical obstacle, and also the issue for the local content of movement of the material used by the two-way methods or EMI. I hope that this webinar can facilitate all participants to discuss and sharing about the success of EMI implementation of some area in other countries, so PLN can get the comprehensive illustration of EMI implementation in Indonesia. Thanks for the delegation from India and Malaysia who are willing to join this webinar to share their success story with us. That's all from me. I hope this webinar and all discussion which will be delivered today are useful and beneficial for all the participants, especially for EMI implementation in Indonesia. Thank you. Stay healthy. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Pak Bob, for the heartfelt welcome and also for your insights and your wishes for the webinar today. We now will move on to the panel discussion. As mentioned previously by Pak Edi in his opening, we have 5 speakers for today, delivering the Indonesian perspective, the Malaysian perspective, the Korean perspective, Indian and international perspective on smart meter, especially on AMI or advanced metering infrastructure. I would like to welcome the first speaker of the panel, Mr. Ignatius Rendroyoko, currently serving as Director for Electricity and Wholesale Business for PT Icons Plus, a subsidiary of PT PLN Persero. Pak Rendroyoko, the stage is yours. You have 15 minutes, Pak. Okay, it looks like, oh, he's ready. Pak Rendroyoko, are you ready for your presentation?
Yes, of course.
Yes,
thank you very much.
You have 15 minutes. Thank you.
Okay, I will share my presentation. Yes, this is my presentation. The title is the same with the webinar, the topic of a webinar today, smart meter opportunity and challenges. But in this presentation, I would like to mentioning more specific to the AMI implementation and preparation. Ladies and gentlemen, let me introduce myself first. My name is Ignatius Rendroyoko. I am the Director for Electricity and Wholesale Business of Indonesia, PT Indonesia Comnet Plus. And Indonesia Comnet Plus is one of PLN subsidiary company that has the duty in taking care of the telecommunication and information technology services for PLN and for other external companies. Okay, in this slide, I would like to share short things about what is advanced metering infrastructure. Yeah, advanced metering infrastructure is new technology in metering system. It is more complex but more flexible measuring system that has the ability to communicate between the meters to the data concentrator unit, and also the data will be transmitted into the head-end system and the metering system, metadata management system in center of the metering system in one utility company. The part of the advanced metering infrastructure is the smart meter itself, and then the telecommunication media. In this case, PLN has already announced that they are choosing three kind of communication media. The first is using radio frequency. The second is using power line communication. And the third is using GSM and also fiber optics. The implementation of AMI is, everybody says that advanced metering infrastructure is the fundamental for smart grid implementation, because advanced metering infrastructure is taking care of all the measuring system from the generation side, transmission side, and then the load itself, the substation, PLN substation, utility substation, and also from the customer itself. AMI is not really a single technology, but it's using many technologies in this case of putting the telecommunication and information technology into the electricity power networks. So the system of the smart grid will be much more smarter than conventional one, because it has the capability of the metering system, smart metering system advantages. Okay, then this is in these slides I would like to discussing about the journey, the road of PLN in moving to our previous technology, the AMR system, into the AMI. Icon Plus has the experience and expertise for almost 5 years in taking care of the operation and maintenance of the automated meter reading for PLN. We started in 2016. We developed the AMR system by ourselves with the support and helps from other companies such as smart meters company, also academics institutions, and also from other public company to support us to mastering the expertise of metering system. In here we can see the difference between the AMR and AMI. AMI has the advantages in 2 ways: communication, yes, so the measuring system can be done more frequent, so the customer will have information continuous and almost real-time measuring system from their usage of electricity with this technology. And then the AMI itself, by using that kind of services, the advantages, it should be customer will have the capabilities in managing their usage and controlling their efficiency of electricity usage. This is a utility business process. So in utility process business, there are metering services is provided, is prepared by utility company, and is organized and also improved day by day. For one side, for the utilities company, the good metering system will help the company to make sure the revenue, the energy sales, and then for the customer, it will help them to know more exactly how their usage of the electricity energy, and also can support the how they can control, how they can manage, how they can improve their electricity usage in terms of efficiency. This is the components of AMI. Like what I said before, the advanced metering infrastructure consists of the smart meters in the customer, for residential customers, also for business and industry. And then there is a communication network. In this case, like I mentioned before, that PLN has announced that there are 4 kinds of communication media is already mentioned, already chosen to be the telecommunication media for AMI implementation. The first is using fiber optics, and the second is using radio frequency, and the third is using power line communication. There are 2 kinds so far, 2 kinds of power line communication. We know about the broadband PLC and also the G3 PLC. Sorry if I may saying something like a brand. And also we are now using the cellular for transmitting our data, is the mostly for the our AMR system at the moment. The data, if you will see here, for the RF and PLC, we are using data concentrator unit. That's it has the function to collect all the data from the meters and then transmit it directly to the head-end system, and also to the metadata management system in the center of the metering system of the utilities. This is the details about architecture of AMI metering system. Again, this is the first thing is about the smart meters, and then all the measuring system is the data from the measurement will be transmitted using modulator and demodulator equipments to the using communication devices. It right into the data concentrator unit, and then using fiber optics, the data from the DCU will be transmitted also to the head-end system. Head-end system has the function to collect all the data from many meters through the DCUs, and also doing the first security system to control all the data transmission. And then after that, after the data is collected from the head-end system, the data will be transmitted into the matter data management system, where the data analysis and data management and data warehouses will be done in the metering system. This is the evolution from AMR to AMI in PLN. Before, we have and familiar with the modem and cellular technologies, and going to the AMI technologies, we are introducing the other communication media, PLC and radio frequency, using another parts of the data concentrator and also the head-end system. And then we are also having a new kind of streaming platform to regulate, to organize how the data can be transmitted into the metadata management system, and then doing all the data analysis and data analytics to have all the data will be ready for another evaluation and appealing. Thank you.
Bapak, you have 3 minutes left.
Okay. This is our projected Smart Meter Operation Center. This is one new services developed by ICON to PLN, and all the AMI operations will be monitored and serviced here. And then so all the things will be monitored and make sure that everything will be working okay. And also the data analytics and another action followed, another follow action can be done by the engineers to have the data is used properly. This is the best effort in cellular telecommunication. The principle of this is we are trying to manage the cellular communication even more rapidly. So all the data transmission can be guaranteed in successful rate. This is the coordinated push model on meter readings using before we are using smart modems, and now we are using data concentrator units for our projected AMI system for PLN. That's all my presentation. Thank you very much for your attention. And if you have any comments, any questions, and for discussion, I will be very happy to have that with you. Thank you so much, and have a nice day. Thank you.
Thank you very much, Bapak Ignatius Rendroyoko from PT Icons or Indonesia Comnets Plus for your presentation. Ladies and gentlemen, if you do have any questions, be sure to drop them in the Q&A box. Please state your name and your affiliation or your organization. And also please state who you are directing the question to. We will be selecting a few questions at the end of this panel presentation to be read out and to be addressed by the speakers. Now, I would like to invite the second speaker of this panel, Mr. Dr. Zainal Arifin, also from PT PLN Persero, the Executive Vice President of Engineering and Technology, as well as a lecturer at the Institute of Technology, PLN. Pak Zainal, are you with us? Yes. The microphone is yours for 15 minutes, Pak. Bapak, silakan Pak di-unmute. Please unmute yourself.
Okay.
Yes.
Good afternoon, everyone. To save time, I would like to start my presentation. I only focus to the challenge, because for LMEB, we only see the challenge, not the opportunity, but that's implementation. So I would like to start with the, okay, if we talk about MI, actually MI is not, totally new in utility industry. Today, more than 700 million AMI has been installed around the world, and the largest we can see is still in China, because SGGC, the largest utility company, has installed almost 500 million MI around China. So, of course, we can look at other experiences from utility for benchmark how we do the effective MI implementation in Indonesia. If we look at to this table, we will have at least 10 utility companies in different countries who already implement and develop MI, from France, UK, Korea, China, Italy, Ireland, Austria, Sweden, Canada, and the last one in Netherlands. So why I show this table, because we would like to know how actually some utilities has implemented MI successfully in some different context. Maybe the electricity grid system is different among the country. The business model also different among the utilities. So we should look at to the other utilities experiences, for not, like we cannot start. We don't want to spend any time, wasting time only for doing the same mistake like that. So based on the benchmark, PLN did, actually we have 5 main points. The number one is MI actually is not copy-paste technology. Based on the previous table, we can see that the most use of communication technology for MI is actually PLC, mostly in China, also in European country. But the technology, like I mentioned, is not copy-paste. Technology which has been successfully implemented, work well in some country, this cannot be also we guarantee that technology will work well also and our country like that. So the point, we should do the POC, we should do the pilot project first to ensure that technology is suitable with our needs, with our existing grid in Indonesia. And the second point is MI is about infrastructure, about system. It's not only about meters. It's not only about the smart meters. So this technology maybe is like relatively new for the smart for the meters vendor, because before that they only focusing to produce the meter itself. But for MI, they should think about the system, about the infrastructure, about the ICT, instead only of the meters. And number three, we have a lesson learned that no single technology solution for all customers. Even though in one country they have some majority technology has been used, but they cannot rely on only one single technology, because this the basic. I mean, I think every technology has their own advantages, but also their own disadvantages. Maybe PLC is very useful for the urban. Maybe RF will be useful for more remote area like that. So we have no one single solution. And number 4, based on the previous table, we can see that before the commercial rollout, MI implementation needs a trial. We cannot jump based on the 100 meter installed in our existing grid. So we have the test and the result of the small-scale project, and we can conclude that the technology is suitable, is feasible for our system. Then we jump to roll out commercially to, for example, 1 million meters. It's not the way the utility implements MI. And the number 5, we can also actually, based on the table, that the cost indeed will be different among the country, because MI cost structure may be a little bit different, or maybe so far different. It depends on the context of the MI itself. It depends on the economical, the business model, and so on. So we have 5 lessons learned from the previous MI rollout has been successfully implemented in other countries. So if you look at the Indonesia case, actually, as already mentioned by Pak Bob, PLN has done with several pilot projects since 2018. So we have some technology, we have some location to shoot. So we already done with several pilot project, POC, maybe we call it a small scale POC, and we need to go to the next stage, based on this journey. Actually, PLN already had sufficient knowledge about the MI itself, about the basic communication, about the communication standard, about the matters feature itself, and so on. So I think is the best time, is the good time for PLN to go to the next step. So the challenging number 1, I think, is technical issue, which is the most suitable technology for Indonesia. Actually, if we talk about the combination of technology, basically only divided into 2 types, wireless and wire. But if we look at more detail inside that, it's both technology, we will find so many options, several technology with their own advantage, also their own disadvantages. So this the first homework we should do in Indonesia, to choose, to select, to assess, and to define what kind of the technology will be most effective for PLN, for customer also. The second one is about how we do MI clustering, because MI basically is infrastructure, is system. The rollout, the implementation should be based on the territorial clustering. We cannot put MI scatter, because the MI will be useful if the location, the system will be at whole territorial to in one location together. So based on our demography, our topography of our customer, Indonesia right now has at least 78 million customer, but they they live at several islands, so many islands with various condition of grid electricity system, about the reliability, about the power supply, quality, and so on. So the second challenge, how we do the clustering to achieve the effective, the best implementation of MI. And also we should consider what strategy we would like to do with the MI. We can look at here. Actually, there is three basic of strategy for delivering MI based on the functionality or the number of meters. The number one, we focus on the functionality. We first create the meter is best as we can, and after that we roll out the meters or the system. And then number two, we only care about the number of adoption. The functionality can be done after that, after achieve such number. And the number three is hybrid. So we can take the rollout by increase functionality and also increase the number of adoption at the same time. This the three basic of the strategy for rolling out the MI, instead of the how we do the clustering well. Next, yeah, is also already mentioned by Pak Bob, yeah. In Indonesia, we cannot import technology if the technology has been made, has been produced in Indonesia. That's the basic rule, the basic policy in Indonesia. So, because we already had the industry of meters, so we cannot deny it. We cannot import for smart meter directly. All everything should import here, because we already had the industry. We already had the capability for this technology. So how much you can go? We try to define the roadmap for local content of MI. You can look here, maybe this year, because the state is still pre-commercial, we cannot rely on the local vendor to provide the technology. It's okay. The local content may be minimal, the small number, maybe 10%. But after that, after the standard has been established, the local vendor already produce the prototype, follow the smart meter, we refer to the standard of PLN, we can upgrade the local content to be at least 40%. And next, we will achieve a larger local content. And also, we hope that at the end, at least for the MI, we can achieve minimum 80% of local content can be achieved by the Indonesia capacity of industry.
Pak Zainal, you have 3 minutes left.
Okay. And now number four is about how far PLN wants to go. Yeah, it's mean about actually what the objective of PLN to deploy MI. So we can look here that MI actually have core application. So it should be exist at the whatever maturity level of smart meter. They should have this meter reading, communicate reading, meter data management, integration, customer care, and billing. But the utility can improve here the capability of MI with the optional application support, and at the end can create some new product or services beyond electricity like that. It depends on the target objective of the utility itself. And this is maybe only in Indonesia case. Yeah, we have the difficulty to optimize when we want to apply MI, we should do replacement. But at the same time, we also have mandatory to replace the existing metal based on the regulation. So for example here, instead of MI, actually we should do replacement so many number, more than 16 million. So how do the optimization between MI installation versus the methods replacement we supposed to do in the same time? This also the homework. And also the last homework, we should ensure how feasible MI in terms of financial. Because if we look at to the previous table, and we did some interview, a lot of the utilities still not still doubt about they already whether they already had the feasible of the implementation or not, because MI actually has direct benefit and indirect benefit. The benefit will be achieved based on some certain condition. That's also not easy for utility can achieve this benefit. I think this all of my presentation. Sorry for extend my time. Thank you for your attention and good afternoon, everyone.
Thank you very much, Pak Zainal, for your presentation. So many valuable insights about PLN and the challenges, as you said, of adopting smart metering. Now I would like to hand over to my colleague, Mr. Muhammad Reza, also from the Indonesian Smart Energy Association. He's going to host the remaining half of the panel discussion. Please, Mas Reza.
Yeah, thank you very much, Ditri. So everyone, now I think we have heard about this advanced metering infrastructure, opportunities and challenges from Indonesian perspective. So now we will have the third speaker within this webinar, Professor Dato Muhandas. Professor Dato Muhandas will share the experience of advanced metering infrastructure development in Malaysia, and Professor Dato Muhandas is from M-Cube's Consultancy Malaysia. So please, the screen is yours.
Thank you very much. Can I get somebody to put up my slides?
Slide-nya bisa di-sharing. Yeah, thank you.
Okay, very good afternoon to everybody.
Can di-enter lagi? Yes.
Okay, I'm Mohandas from Malaysia. I used to be with Tenaga Nasional Berhad, the electric utility in Malaysia, similar to PLN in Indonesia. I was the project director of the AMI project in Malaysia. So I was the one who set up the whole project. I have got first-hand information of exactly what Malaysia is doing and how we started on this journey. Okay, can you go to the next slide? Okay, so I think smart grid worldwide drivers, if you notice, these are the main issues: high customer demand, high dependency on fossil fuel, increasing cost of supply. Everybody goes into smart grids basically because of these issues. So, okay, next slide. Okay, so digitalization and smart grid initiative around the world. When Tenaga Nasional Berhad in Malaysia started, we looked at all this, what was happening in the US, what is happening in EU, what is happening in the UK. So many things have happened during that time. So we also went on the bandwagon, jumped on the bandwagon based on all this that was happening around the world. Next slide. Okay, so we did quite a bit of benchmarking. If you look at the bottom, right side bottom, you can see TNB Malaysia. So what we wanted to do at that time when we started, we wanted to win the customer's trust and confidence to tariff options and value-added services, benefits to departments and utilities and Department of Environment, promotion of lifestyle. These were the main driving factors for us when we started on this journey of this smart grid and AMI. Okay, next slide. Okay, so this was what was happening during the time. This was in the year 2013, 2014, what was happening in smart grid deployment in the US. I think at that time they had something called the OMABA funding, where the US was giving funds to the utilities to make sure that they come up with smart grids, and a lot of smart meter initiatives happened in the US during that time. Next slide. Okay, so what are the benefits of smart meters in the eyes of TNB at that time? Okay, first thing was the smart apps. Could do a lot of automatic and remote meter reading. You can do load profile readings, electricity consumption information. You could do outage management, and then the smart payments. You can also do connect and disconnect on the meters, and then you come out with time of use billing. You can do demand response, data management. So quite a lot of things. And then for later, you're supposed to go with EV, electric vehicles, and the PV meterings. So these were also the driving forces behind TNB getting into the smart meter journey. Next slide. Okay, so this is the TNB's AMI journey. So I remember that the earlier two speakers, Pak Dr. Zainal Arifin and Rendo Yoko mentioned, that PLN is going on this. But in TNB, what happened was we actually did a small pilot project. If you notice the small pilot project, there was only 1,000 smart meters done in the state, in just two small states, Melaka and Putrajaya. This is how we started the journey. And we just wanted to do just a few things first. So we wanted to enhance customer service, we wanted to do demand response, we wanted to do revenue assurance, and it's just 1,000 meters only. This was how the smart meter pilot project started in TNB. Next slide. Okay, so the contract was awarded somewhere in early 2014, and it completed somewhere in late 2015. It went up to early 2016. So the 1,000 meters were installed, and this project was actually paid by the Malaysian government. Malaysian government paid for this. It wasn't paid by Tenaga Nasional Berhad, TNB. So we had a few learnings from this, lessons learned from this, before we moved on to the complete project. Okay, next slide. Okay, so when we did this pilot project, this is an interesting slide. This was a study done by a university in Malaysia, and they did a survey on all the customers that were given the smart meters in the state of Malacca in Malaysia. And when they did this, these were the main findings of the university when they did a survey from the customers. So what the customers wanted from a smart meter was outage management. I mean, notification when there is a blackout. This is the key thing that came out of the survey. We made sure that it was done by a third party, which was a university. And then the customers wanted smart home application, supply automation, automatic billing. These were the key findings of the research done by the university when we did the pilot project. Next. Okay, so we also came out with a smart meter web portal. So there was a portal where the customers could go in, and this was how the portal looked like. You can go in there, you can have a look, and you see what is the cost, what is the impact of what you have done. Okay, next slide. I'll show you something else. Okay, here it shows you exactly your consumption by every day. It can give you consumption every half an hour as well. So as a smart meter customer, you get so much of information as compared to now. When you did not have the meter, you only get a bill at the end of the one whole month. You don't even know how you use your electricity. So using smart meters, this was given to the customers during the pilot project. completely all full details. They also know when their bills goes too high up, which are the days that the bills go higher, and days when they use very little. So all those information are available to the customers. Next slide. Okay, there you can see the half hourly readings from 12 midnight right up to the day midnight again. So half an hour, daily during the day, if you're staying in the house, when you go out, how is your consumption? So complete details are given to the customer. They can just log in to the website and get all the information. This information is only for individual. You can't take your neighbor's information. It's all password protected. Next. Okay, so the performance of the technologies that was done during the pilot project. Okay, these were 3 technologies. That's why I think PLN mentioned that planning out 4. TNB only used 3. So basically we used the GPRS or the 3G, and then the RF mesh and PLC. These were the 3 technologies, communication technologies that we use. Then similarly, we got a head-end system, and then the meter data management system, and then it links, integrate into the billing systems. And what are the new things, the new features that we want to do: shutdown notice management, call management center. So many things that we started integrating into the AMI services itself. So time of use pricing, all these were part and parcel of the whole project. So this is the infrastructure, the architecture of the AMI that was implemented in TNB Malaysia. Next. Okay, so while we are doing this, this is actual results of what happened for the communication. You can see some of it totally down. So the whole network went down. When we're doing RF, the RF extender bridges, they call it extender bridges. They are more or less like antennas. They went down for a few reasons. So we did a lot of study to find out what the issues were. We had some problem with the modem, some problem with the antennas, so many things. These were all lessons learned where we used it when we went ahead with the future project. Next. Okay, so these were the lessons learned. Meter data arriving very late at the head-end system. The cellular collectors unreachable because of some network issues. The DCUs were unreachable because of some third-party network. A local area network interface. So there were many things. And then there were issues with the meters itself. Some meters using backhauling had a problem, couldn't report correctly. Some were using excessive data. So these were all lessons learned when we were doing our pilot. Next. Okay, so summary of just this pilot project, we completed it 100%. The main features, AMI features, successfully delivered. So we had some of the things delivered. There was some of it that was not fully delivered. We were still testing it. But there was one issue in TNB at that time because TNB was changing the billing system. It was an SAP system, but we were changing the billing system to a new billing and customer relationship management system. So because of that, there were some delays and there were some integration issues between the meter data management system and the billing system. Okay, so there were other findings as well, like high meter failure rates. The meter, because the numbers were very small, the meter manufacturers did not deliver high quality meters at that time. Okay, next. So this is the TNB's nationwide rollout map. Okay, if you notice on the left, the pilot project was on 2014-2016, that 1,000 smart meters that was down. Then as you moved up, you go to first phase. First phase was 2017 onwards, also done in a controlled environment. So we didn't go in a big scale. It was about 340,000, also just done in one geographical area in Malacca, in the state of Malacca. So it was easy to control. We didn't do it all over the place. Completely there, using the same, again, the three technologies again. We did it there. And then we moved to the second phase for 2019 and 2020, about 1.2 million meters in Klang Valley. So at this moment, as at yesterday, we've installed 1.14 million meters already in Malaysia. 1.14 million. So that means we are on target. But since we mentioned about 1.2 million by end of this year, 2021, it should be able to achieve that numbers. There is a slight delay because of the COVID situation last year. So, and finally, If you see it right at the end, complete about 8.5, roughly by the time it should be about 9 million customers for TNB in Malaysia. So you should be able to complete it in another few years, and with the full support of the government to do this project. But do you think if you notice this slide at the bottom there, there's a word called industrialized processes to need to be established. So if you don't get these processes done properly, then you cannot roll out the big numbers. So we need these processes to be in place. Next slide.
2 minutes more, Dato.
Okay, next slide. I'll go fast. Okay, so this was the nationwide deployment plan. Next. Okay, so lessons learned from the pilot project. So we need to do a cost benefit analysis. We need to do cyber security. This thing normally will be forgotten by many people. We need to do a risk analysis. Then we need to do a full deployment and stakeholder engagement and communication plan. That's very important. You need to talk to the customers. You need to talk to the government. You need to talk to everybody, and you need to have a proper communication plan. Go next. Okay, next. Okay, we did a thorough cyber security, doing all zonal checking at the communication side, at the head-end side, at the MDMS side. We had many findings, and we used this when we did the full rollout. How do you make sure that you have a proper cyber security at the whole from end to end? Next. Okay, next. Okay, next. Okay, these were the risks that we identified. In fact, when we sat together, we got about 50 over risk for this project. Okay, next one. So what you need to do when you do the full deployment? This is a very interesting slide. You have got a software side on the left side, the network and all that. On the right hand side, you have the meters, the hardware side, mostly on the hardware, the operation center. And then you have got the change management. How do you do a transformation of your meter readers that you already have now, the staff that are doing manual work, the engagement that you need to do with the stakeholders, and the features of the meters on the left. So if you look at it, this is a complete picture of the smart meters where you have got technology, the communication plan, and the operations. This slide is very interesting. If you get this, you can see the whole scope of the AMI here. Next. Okay, so in TNB, we built the command center. This is how it looks like. If you all got it, can make a visit to Malaysia, visit TNB. This is exactly how the command room looks like, the smart meter operation center. So it's not in theory, this is the actual one. Next. Next.
Okay, the time is.
I'm going to run through for next. Go next. Just give me 1 minute. I'll finish. Next. These are just the pictures of the command center. Okay. Then these are the stakeholders. What you need to be done. Major challenges is convincing the regulator. Submission for the incentive-based regulation. We had issue with the billing, dealing with the international vendors. You have quite a big challenge. And then there will be a lot of delays in tender awards, re-tenders, and staff redeployment, especially when you have meter readers and you deal with their unions, you want to reskill. This will be a big challenge, besides just installing meters. Next. Okay, so DLMS, I think somebody spoke about this already. So you better get your standards in place when you get the DLMS. Next. 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 Okay, cost benefit. Okay, next. Okay, when you're doing cost benefit, make sure you have all these components calculated, and then you know whether it's worth doing this project. If you don't have all these components, probably you would have left out, you'll get wrong information. So these are very important when you do a thorough study on your cost benefit. Next. Next. Okay. Next. Okay. This is something also that's always forgotten. The previous slide, please. Previous slide. Go back. Okay, this slide. This one is normally forgotten by most of the utilities when they do this. Your transition, when you're moving from normal metering to smart meters, there will be a lot of changes in the jobs that's being done by the various other departments. So you have to do this transition management, moving from one department to another. Okay, next. Okay, thank you. That's all I have. Thank you very much. Sorry, I overshot by 1 or 2 minutes.
Thank you very much, Professor Mohandas. So we have heard the experience from Malaysia, I think from the real experience of implementing this AMI. So now we will move to the next speaker, Mr. Peter Jung, who will share with us his experience on this advanced metering infrastructure development in Korea. So please, Peter.
Okay. Okay, thank you very much. Okay,
We have also 15 minutes. Yeah.
Okay, sure. No problem. Okay. Okay, can you see, right? Yes. First, thank you very much for invite us. So today, I want to explain about the AMI deployment in Korea for power infra digitalization. Okay, my name is Peter. I'm in charge of energy new business in Korea, and also we are one of the strong provider and solution company for AMI system, very close to KEPCO. Okay. As you mentioned already, many speakers mentioned about the purpose of the AMI system. The main purpose is the encouraging customer to reduce energy consumption and also provide the infrastructure for demand and response program. So as you can see, the AMI service structure already, Mr. Bayok already mentioned about this one. So from the smart meter to MDMS, the lower system from the smart meter and modem and DCU. Each smart meter installed in each house, and metering data is moving to head-end system, and head-end system collecting the all metering data and deliver to MDMS, meter data management system. And normally MDMS controlled by utility company, and from the smart meter to head-end system, and solution company provide to utility company. So then why AMI? The digital infrastructure of energy, smart home, smart building, smart city, and smart nation. So monitoring the accurate power consumption and status in the field and quality of energy for energy efficiency. And also number 2 is demand and response, and minimize blackout, SID and SIP, and peak demand control. We can do with this AMI system, and more accurate forecasting of power consumption, and accelerating renewable energy, and electric vehicle, and microgrid. And also number 3 is very important, TOU and flexible tariff. A different kind of the tariff can be adopted with TOU information. It's the business side and industrial, residential, and day and night. And the number 4 is so very important, loss detection and remote control. And detect the loss, and then we can go there in the field and then reduce and minimize loss in the field. And 2 kind of the loss, technical and non-technical. And also efficient operation and remote control of energy with a server system. And this is the in Korea situation. And AMI deployment, the total household is customer 32.5 million house. For individual house, 69%, around the 22.5 million household. This 69% house controlled by KEPCO directly, but another 31%, around 1 million household, is kind of the apartment house. The apartment house controlled by apartment management office, indirect by KEPCO. This is I want to explain about the 22.5 million, the individual house case. So far, 10.22 million household already installed. So there is the plan and already achieved. So based on our plan, we have to finish 2023 and all to 2.5 million households. So there is some delay from the 2019 to 2020 because they're applying the security technology. Security technology means the encryption technology. So in Korea, so you know the KEPCO and Energy Ministry in Korea trying to adopt a very special encryption technology for AMI. So as you know, the North and South Korea, so that's why the infrastructure is very important from the hacking. So that's why we adopted very special government certified security technology for 2 years. And the 2023, we will finish all through all 100% AMI system in our country. And for apartment AMI deployments, just starting from the last year, 2020, total 10 million household for apartment. So last year, only 400,000. And from this year, 1.4 million household, and we can finish within 2024. So this is kind of the government, Green New Deal government project. And I want to explain about what technology is using for AMI system in Korea. We also, TMB and BRN, many utility company trying to POC in Korea also, KEPCO trying to, what is the best solution? So final choose technology is the broadband PLC and cellular and RF. But RF is just 4%, is rural area right now. And main technology is this 68% with broadband for city and density area, urban area. And rural and island is 28% with a cellular and mobile, it's GSM and NB-IoT and things like that. And we tested in 2015. At the times, on the ground power line, there are so many noise inside. So that's why the communication problem at the time. So that's what is good. So broadband and narrowband, we tested by KEPCO and Energy Ministry. And finally, KEPCO and Energy Ministry choose the broadband PLC. For AMI system, the smart meter and shall be follow the DNMS COGEM international standard, and the communication side and PLC power line communication and mobile and LTE or NB-IoT, and also DCU, the gateway and head-end system. And each house just one smart meter, and then the smart meters can connect to the DCU. And two kind of the DCU installations, one is the pole mount, and another is kind of the shelter or the install on the ground. And MDMS, Mr. Yoko from the Icon Plus team explained in detail, but the Korean MDMS also developed by KEPCO, by themselves. And right now for 110 million household is connected to that MDMS, and all data is moving to MDMS. And MDMS can provide a variety of functions for advanced metering. As you can see right side, the power consumption or many functions for utility company. And there is the head-end system and MDMS, two kind of server system. How many servers in Korea? So the 15 head-end system in Korea. So this head-end system installed in each branch. And each branch means that in Korea, there are some province, one or two head-end system in each province. And only one MDMS system in KEPCO headquarters in Naju city. So then our AMI system is going maybe over 2 or 3 and 4 years. All country can be deployed with AMI system. So then right now, KEPCO and Energy Ministry thinking about the EV car charging based on the AMI. Because the real-time based monitoring the energy consumptions of the building and facilities with AMI, And based on that, energy EV charger can be controlled automatically by server system to operate more reliable EV charging server. So that is kind of the citizen demand and response program and zero carbon and government project. So one place is the power consumption is the limited. So to deploy the new EV car chargers shall be make more bigger capacity. That is to spend a lot of energy. So that's why we monitoring the power consumption and balance power capacity, and then we can very smart monitoring and control the EV car charger. That's the best way for the building an apartment or some another place. So surplus electricity to use for EV system and EV charging power consumption data is moving to the AMI. So we are thinking about this new concept for smart grid projects based on the AMI. I briefly explain about our company. Tide is one of the strong AMI supplier in Korea and developer with KEPCO. So we already developed and we already deployed the 2 million household in Korea. And there are some pilot project in overseas market. So we have smart city and AMI platforms from the EV charger to AMI and smart lighting control system. And we have two kind of the project in Korea, in Indonesia already, in Cengkareng area, and with the MDMS POC with PRN Pusnipa. Okay, thank you very much.
Okay, thank you very much, Peter Jung. A concise explanation about your experience in Korea. I think for everyone, we have a Q&A, so you can give your questions and we will answer later in the end of this webinar. And now we will move to the fifth speaker. We will have Mr. Reggie Pillai. Mr. Reggie Pillai, which is President of Indian Smart Grid Forum and Chairman of Global Smart Energy Federation, will speak and share the experience of general challenges and opportunities of implementing MI in India and I think globally. So Mr. Reggie Pillai, please, the screen is yours.
Good morning, good afternoon, good evening to all the participants attending from around the world. Thank you very much for inviting me for this very important webinar on smart metering. Smart metering has started almost 2 decades ago, starting from North America to Italy to different other places. There are a lot of experiences, a lot of lessons learned available, which are relevant to every geography. But still, if a large utility need to embark on a big AMI program, as Dr. Sainal has rightly said, need to test the technology before large rollouts. And my previous speakers have told about different very important experiences and lessons. And I will start with some of the advantages of AMI, although the risk of repeating some of them, but like to articulate some few points, particularly with the AMI, if it is properly implemented. When I say properly implemented, all the meters, all the customers in a particular feeder are brought under the AMI scheme. Then we can have fine granularity of the granular visibility of energy flows on the distribution grid. Today, on the low voltage and medium voltage grid, the energy flows are not known to the system operator. With AMI, we get that almost near real-time granular energy flow to every customer. And that also gives us ability to do near real-time energy accounting feeder by feeder. When you are able to do that, you will also be able to know phase imbalances. The phase imbalances in the low voltage line. It is very typical that one or two phases are overloaded while other phases are underloaded. So those things can be corrected with this visibility. Otherwise, utility get to know only when a distribution transformer burns that there was overloading or there was a phase imbalance. These things can be corrected almost in accurately. And this also brings us to the clarity on how much of electricity is lost because of technical losses, how much is lost because of commercial losses. The classification between commercial losses or including theft and technical losses are not today available transparently to a utility. So that is another major benefit of AMI itself may not reduce the losses, but AMI gives you visibility and appropriate managerial and technical measures can be adopted by the utility for reducing the losses. And another very, very important thing is that granular level demand estimation. Today, utilities are not able to do. With the AMI data, every half an hour, 15 minutes in India, we do 15 minutes consumption data we capture. So 15 minutes, half an hour or 1 hour data, which you are collecting, it gives you exact information, who uses how much electricity, when and where. And with that information, your estimation for tomorrow's consumption, your estimation for next week consumption, your estimation demand for next month, that can be more accurate. The power purchase cost can be reduced. You need not contract for power which nobody going to use it, which today we do not know. A couple of speakers have talked about the TOU, the time of use tariff, which can be implemented with TOU, and that is going to be the future. In the good old days, we actually implemented a time of day tariff plan. The utility knew exactly evening 6 o'clock to 10 o'clock is my peak, or morning 7 o'clock to 10 o'clock is my peak, which is not today for two reasons. One, lifestyle change, the climate change, and also more and more renewable resources, the generation resources has coming from renewables. So in Delhi, for example, last 4 years, our peak, summer peak is in the midnight when everybody is home and people are using air conditioner. So time of day tariff, which we practice, are no more relevant. It has to be more time of use. Many days during the day when, and now we operate our power system with the 15-minute interval data. So that is 96 blocks. Many blocks during the day when solar and wind both are producing, we have surplus electricity. I would be able to send price signals to my customers and those who are joining my TOU again. I can offer electricity at a rebate. I can pre-cool a building. They can convert many of their activities during that time. Similarly, peaks or shortage, supply demand gaps, which can happen anytime during the day, I can send pricing signals to customers, and they can shift some of the loads which they can shift. So another major benefit is that if you take any city or any town, the peak, summer peak happens, the last 100 megawatt or last 200 megawatt of the summer peak happens for less than 100 hours in a year. So typically what we do today, we have the generation capacity, transmission capacity, and distribution grid upgrade. All that is done for that last 100 or 200 megawatt in a town where it is utilized less than 100 hours in a year. So with AMI and TOU tariff and other demand response programs, we will be able to incentivize customers to shift their peak and reduce that 100 megawatt or 200 megawatt every year, which will help in deferring system upgrade for generation plants, as well as deferral of millions of dollars of system upgrade for transmission and distribution system. And with all that, emission reduction, which is one of the another major advantage, you detect outages easily even before customer do it. You exactly know where the outage is, that the truck rolls, comes down, the emission reduction happens. And as far as the challenges are concerned, again, all the speakers have talked in length about many of those challenges. So one is about the meters, a standard meter. I'm happy to note that Indonesia has adopted DLMS COSM, which is IEC 62056. It's very good. In India also, we adopted that. Our smart meter standard is conforming to that. So different makes of meters conforming to 62056 data standard can be part of the AMI rollout. You don't need to marry only one meter make, which has happened in many countries. So on the communication, the last mile connectivity continues to be the major challenge, and there is no uniform solution. Again, as the previous speaker said, it is not a cut and paste solution. What worked in Jakarta may not work in Bali, may not work in another island. So same is the case with what happened in USA or Europe, may not work in India. We tried many technologies, many things, but our major rollout is yet to start. I will come to that later. So I would like to talk about one or two major technologies which people have been trying. LoRa is successful in many places, but in places where you look for more load survey data from the meter. So all our experiments in India, LoRa failed to download load survey data from a 3-phase meter. So nobody in India is now using LoRa for smart meter rollout. NB-IoT is promoted by our telecom operators. The small pilots have happened. Recently, Delhi has ordered for 100,000 meters. That rollout is yet to happen. And some other telecom operators talking about 5G, and that 5G is yet to come. We don't know when it will happen. So waiting for 5G perhaps may not be the right approach. But another two important trends which you may like to note are the latest G3 PLC Alliance experiment with a combined PLC plus RF mesh trial, which they have done in a couple of countries, and they want to do one in Delhi as well. Because of COVID, it got delayed. So that is a interesting technology. Perhaps if it is cost competitive, should look at it for different terrains. Another trend I have seen in North America is that utilities are building their own telecom network. Why are they doing so? So particularly in the electrical cable, when you are replacing or when you are laying new cable, or in places where overhead line you are converting to underground distribution line, you go for a cable which is marginally more expensive, but it has fiber optic cables. So in Bangalore city last year, we embarked on a 7,000 kilometer overhead line to be made underground line. Those cables, we are putting 192 fiber cable into it. And the total project cost has gone up only by 7%. So only 2 or 4 pair of fibers will be utilized for the utility operation. Rest of them already telecom operators are asking for it. You have the right of way, you are doing anyway, and you can build your own telecom network. This will help all your data concentrators can be on your own fiber network. All your distribution transformer can be on your own fiber network. All your substations can be on your fiber network. That will be a great advantage. So another major challenge is the system integration and integration of the software pieces, the MDM, particularly MDM with the utility application. You have to select an MDM for which you can find a skill set in the market. If you go for a proprietary MDM, only that company which developed the MDM will know how it is, how it works, how different changes can be implemented. So it should be a COTS application, commercially available off the shelves, which are scalable to millions and millions of endpoints. So those kind of systems should be selected. And I was quite happy to hear about the Korea experience. They have 50+ headend, but only one MDM. This is exactly the architecture which we have been, ISGF and GSE have been promoting or advocating. So cyber security has to be a main, a central theme of the digital architecture for the entire utility operation and the integration of OT applications with the IT applications. So I'll now move on to the Indian experience. So as part of a major program,
you have 3 minutes, Mr. Reggie.
Yeah, take 2-3 minutes only. So we awarded 14 smart grid pilot projects from Government of India, 50% grant, and the respective utilities were to be investing in the rest of them. So these projects were awarded to 14 different states in 2013, and they all were struggling how to do. All the projects had smart metering as a central theme. We were at that point in time working on a national standard for smart meter, which we finally completed in 2015. The Bureau of Indian Standard issued IS 16444 as the national smart grid standard. So that is all fine, but utilities will still struggling how to contract, how to maintain, procure the right AMI system, and how to maintain it, because there are different skill sets involved. Besides metering, you need communication, you need IT skills. So in 2016, ISGF published a white paper where we advocated that utilities do not have the capability to buy the right system. Even if they buy the right system, they may not be able to maintain it for 10 years. So utility should go for a metering as a service model and engage a metering services agency who will undertake the metering system, who will select the technology. The utility should have a service level agreement with the metering services agency, and who will be paid no upfront capex payment per meter per month, X dollar per meter per month. So we have done some aggressive costing analysis in 2016, came out with the number that it will be somewhere around $1.1 per meter per month for 1 million meters for 10 years. So that point in time, the meter prices were quite high. IS 16555 meters were available at more than $70-80 at that point in time. Now, when we really started the rollout, the prices have come down, and the government of India has adopted that model, metering as a services. Currently, on the same model, Energy Efficiency Services Limited, which is a government of India company, they have undertaken smart metering in 3-4 states. They have already rolled out more than 2 million smart meters. It's exactly the same model, some 100-120 rupees per meter per month for 10 years. So now government of India finally is rolling out a 250 million smart meter program. The framework is final, standard bidding documents are final, and each of the distribution companies, which most of them are owned by respective state governments, they have been given the framework standard bidding documents a couple of months ago, and they have been asked to submit their comments by end of this week. And most probably in May, government will officially launch this 250 million smart meters, and which is going to be as a metering as a service. The 15% of the project cost will be grant from government of India. Balance 85% of the cost is going to be paid to the metering services agency on a per meter per month basis. So that's a model which is adopted, and that is going to be rolled out. It's going to be one of the world's largest smart metering program. Thank you very much.
Okay. Thank you very much, Mr. Rejik Pillai. So everyone, now we have already some questions, and actually because we want to answer question effectively, so thanks to Mr. Rendro Yoko, so he will answer some of the questions in writing, and I think he has written some answers to the questions. And now we will probably start with some question to Dr. Zainal. Probably you can unmute your microphone, Dr. Zainal. So the question is actually about local content. How to actually have a local content more than 40%, since most of the electrical components in Indonesia is imported. So it's more like the question about how do you think we can manage to have this local content more than 40%, and especially taking into account the R&D hardware and software. And I will also take one question to Dr. Zainal, is about, in this case, how then the producers of foreign equipment, AMI equipment, can actually enter or join into working on AMI project in Indonesia. So Dr. Zainal, probably you can answer the questions. Hello?
Hello.
Yes. So, please.
Yeah, I think it's the easy answer is you should register, and after that you will be evaluated. Should be to our vendor list. That the requirement for everyone who will enter to the PLN market. So this should be at our vendor list first. Maybe this is my question, my answer, sorry.
About the local content, how do you think we will manage to have more than 40% local content?
Yeah, we already discussed many times with the industry. Yeah, not only based on our own assessment or our expectation, but before we put the number, we already has so many discussion intensively with the existing industry. So I think the number is achievable, is reasonable to achieve by the local industry, local company in Indonesia.
Okay. Okay, thank you very much. The next questions, I think D3 will read some question to Mr. Rendro Yoko, please, D3.
Yes, hello, thank you, Reza. Mr. Rendro Yoko, you've got so many questions directed to you. There are many technical questions that we're hoping that you can perhaps answer them in writing directly, but there's one particular...
I'm still trying to answer it one by one.
Thank you. But there is a particular question that I think we would like for you to answer directly. Here from Mr. Singhi. Let me read it out first.
Mr. Singhi, okay.
Question from Mr. Singhi.
Question from Mr. Singhi W. Mukti is in front of me right now. My question is for Pak Rendro. Greeting Pak, I'm Singhi from PT Energy Management Indonesia. Hi, Mr. Singhi. It's very nice to contact with you. The first question is, does AMI that developed by Icon Plus could be used to control the energy use by the equipment? Since what I know, smart meters could not control equipments unless we install sensor PLC on its equipment. Yeah. Okay, for the first question, I will give my answer. The AMI that developed by Icon, at this time, Icon Plus has already managed in developing the master data management system equipment. Yeah, we are just developing the application of master data management system, not the whole of AMI system. But this master data management system is already tested and is already implemented limitedly. I mean, for 3 brands of PLN in Cianjur, in Sukabumi, and in Bandengan area in Jakarta. And so far, based on the evaluation, daily operation, daily, weekly, and monthly evaluation, it works well, fulfilling all the requirements stated by PLN. And we are also doing assessment. How good is the master data management system is fulfilling all the standards, international standard and also PLN standard. That's why you mentioned here to control the energy used by equipment. So no, this equipment, our master data management system or our AMI cannot control the use of energy used by the equipment, but the information that we can get, the information that we collect and analyze, can send the information to customer. So the customer, by using that information, they can manage to control their energy usage by their absolutely self activities. Second, how to overcome the communication challenges, because we know that fiber optics available only in some area, as well as LP1 technology. Yes, you are right. The fiber optics is much more in my works is much more challenging compared to the other technology, because you have to stretch it and put it on the pole and make sure the connection, and testing the connection to make sure that everything, that information can be transmitted correctly and with high reliabilities. The communication challenge, like I said in my presentation, PLN has 3 kind of technologies for the Army implementation. The first is radio frequency, the second is PLC, and the third one is using fiber optics. At this time, not on one communication media cannot solve any kind of area. I mean, in certain area, maybe that's suitable for, maybe most suitably for fiber optics, but maybe for another type, another kind of area, it will be much more, maybe much more suitable if we use radio frequency or PLC. It depends on how the condition of the infrastructure, electricity infrastructure. If the electricity infrastructure is much more excellent, it's good, maybe PLC will be the right choice for communication media. But maybe for if one area, maybe such as in Jakarta, maybe in Menteng or in the PSD, that our fiber optics is already installed, so it will be very good if we use fiber optics. And also if in another area, radio frequency is much more suitable for the condition of the customers area, in such like in the right geographical area, something like that. That's all for Mr. Singgi. And then
Thank you. Excellent, Pak. We're just gonna jump quickly to another question now. This one is to Dato Mohandas. Okay. Before I go there, Mas Rendro Yoko, all of the other technical questions and all the remaining questions, if you could maybe spare 5 or 10 minutes to answer them directly in the Q&A box, that will be great. So now there's a question, actually 3 questions from the same person to Dato Mohandas by Mr. Yoga Yonarai from PLN Batam. Dato, are you with us?
Yeah. Can you hear me?
Yeah. So yes. So in the Q&A box, there's a question from Mr. Yoga. Are you looking at it? Yes.
Yes,
so please go ahead and please give us your answers. Thank you.
Hi, Yoga. Okay. The first question is, can I know how many meter vendors support the AMI project? Okay. In Malaysia, during the pilot project, we had 3 meter vendors. Then when we went to phase 1, there were about 5 or 6 of them. Totally, there are actually about 10 to 12 meter vendors who are doing smart meters, but most of them are still not manufacturing it in Malaysia yet. They are getting support from their principals who are operating from different parts of the world. And the sponsor of our event today, I think VSD Automation, they are actually the largest meter supplier for TNB at this moment. They've got a very big number of meters that already been installed in TNB. Okay. The second question, does TNB manage only one head-end system or follow as many head-end based on the meter that vendor delivered? Okay. The head-end system in Malaysia was actually delivered by the communication provider, not by the meter vendor. So the RF communication provider has got one head-end system, and the PLC provider has got another hidden system. So there are only 2 hidden systems, but like what was explained in Korea as well, there's only one MDMS at this moment. MDMS is supplied by Siemens, which is called e-meter, and the head-end system is supplied by the PLC provider Sejumcom from France, and the RF one is provided by the company called Trillion from the US. So these are the two hidden systems. And your third question, is there any additional revenue outside of AMI project? There are a lot of talk about this, but I haven't really seen any major revenue coming out besides using. So there is talk that, when you put in a good network, the network can be used for SCADA or for other purposes within the utility. But at this moment, there's none. But what I can say is, besides just putting in the meters, the revenue that they come out, if you notice my slide where we talk about the cost benefit analysis, one of the benefits comes from also recovery of your sales that is lost due to non-technical losses, which is actually tempering of your meters. People steal electricity. So using an AMI, you will be able to detect this. So it reduces people from stealing your electricity, I think, which is quite rampant, especially around this part of the world. So I think that's my answers to all your three questions.
Yes, I think, thank you. So I will continue from the three. I think this probably last questions, I will modify from the question from the floor, because we have learned the experience from Korea, from India, from Malaysia, and globally. So I would modify the question about, is there any complaint or what type of complaint that you get in Korea, in India, globally, or in Malaysia about implementing these smart meters? So I will probably start with Peter, and then to Reggie, and then to Dato Mohandas. So Peter, probably you can share with us if there are any complaint on this advanced meter infrastructure in Korea.
Okay, it's very hard questions. The complaint from the customer, you mean?
Yes, yes.
From the customer, actually in Korea, there is no any complaint from the customer because the smart meters belong to utility company in Korea. So utility company change or upgraded smart meter is good for customer and good for utility company. So even though we are some informed to customer, you can check your power consumption real-time based with application, but some customers didn't know that yet. So even though we are around 50% already installed in Korea. So, but in the field, now not so many complaint for AMI system, but only one issue, as Mr. Dato already mentioned, but there is no any good business model based on the AMI system to make the more good profit or something like that. So customer side is certified more clear the billing, and utility company can control the demand response. But some more better business model, business point of view, we have to find a way, and we have to adopting some the EV car and electric vehicle or some another smart grid projects and service. Yeah.
So they are happy customers.
Yes, yes, in Korea, it's no problem. So yeah.
Okay, and Mr. Reggie Pillai, how about in India or globally from your experience? Still muted. Yeah.
Well, as I said, the major rollout is about to start. We have done 14 smart grid pilot projects, of which only 9 or 10 we could complete, which had limited number of customers for AMI, 11,000 to 30,000 average. So there were not much of problems in any of those places. We started bigger rollouts in Delhi by Tata Power Delhi distribution. They have done about 300,000 meters. Its target is 500,000. That is also going on very smoothly. Excellent. And the EESL model, which I said, they have done in Uttar Pradesh and in Haryana. So Uttar Pradesh, there was a bad incident which happened recently last year, middle of the COVID lockdown. So about 100,000 customers, the head end disconnected the meters. So what we are doing, the system, we have remote connect, disconnect. Some malfunction happened, or it was a human error. There are inquiries going on. In August, one day, in different towns, 5 or 6 towns, about 100,000 meters got disconnected, and they took a couple of hours. Most of them they could put it back. but reconnect it. But some of them, they had to physically go to do that. So that has created a lot of what you call public outcry. And as luck would have it, many of those people were VIPs. So very senior government officers, bureaucrats,
And
legislative council members, etc. So that rollout has been temporarily put on hold pending the inquiry committee report. So otherwise, many places we have done work from Tripura to Gujarat, the east to west, and from north, from Haryana to all the way down to Mysore in Karnataka. So not many customer problems were there because they have been, as Dr. Mohandas had told, customer engagement is very key. So they have been told that they will have several advantages. So what are all the advantages to the customers that need to be articulated, and customer engagement be done not directly by the utility, but through other NGOs and other civil society organizations.
But you mentioned about these various states. So how is actually the experience of this deploying smart meters in various states in India? Are you using one standard system, or how you actually deal with many vendors, many systems, many developers? Any comment on that?
You ask me?
How about the experience of deploying smart meters in various states in India, in terms of standard, different vendors, system developers?
Yeah, see, we by and large, all the installations gone on RF mesh as the last mile connectivity, except one in Tripura where they had gone with PLC. So the meter, we have some 7 or 8 meter manufacturers who are conforming to our smart meter standard, the national standard issued by BIS. So as I said, the prices have come down. The availability of meter is not a challenge. Even 2 or 3 Chinese manufacturers, they were manufacturing and selling meter. Some of those meters were manufactured in Indonesia. They were selling in India, which are conforming to the national standard. Recently, last year, there was some issues about the cyber security. So they put some tenders were cancelled with the Exing and other companies. But otherwise, availability of meter is not an issue. On the communication side, the PLC project, about 35,000 meters we have commissioned, and project was working well. But then the technology, PLC technology came from Israel. The meters were manufactured by a local company. Last year, they went bankrupt. So there is no support for that project. In 1 meter as any problem. So these are some of the things which need to be carefully studied. Don't get locked in with meter vendors or anybody who are likely to go bankrupt or who are the system should be supported by market. You should be able to procure things from the market, from the third party, and maintain if your main contractor or main supplier or OEM is gone out of business, or they stop the line of business. So another very interesting example is that one project was done with a grant from NEDO that had about 11,000 meters, and they did along with that SCADA, everything. It's very close to Delhi, Haryana. So NEDO grant, full grant from NEDO. They contracted to a new company in India who manufactured meter. That was not their mainline business. And because it was a Japanese grant, they paid much higher price for the meter, more than $100 per meter. And later, the company was very happy. They developed the meter, they installed, everything went well. A year later, the prices came down. It is $30, $35 is the price of a meter. And they said, this is not a business where we can survive. So they stopped that. So that project is again not supported by the OEM. So this kind of situation need to be analyzed.
Okay, thank you. I think there is a video from VSG will start. Before this question will be given to Dr. Mohandas. So please, Nisma. Nisma, hello. Yeah.
Okay, ladies and gentlemen, honorable speakers, thank you very much for your time. We have spent a good 2 hours together learning about the challenges and opportunities of smart meter in Indonesia, in India, in Malaysia, in Korea, and also internationally. Apologies for those who haven't had their questions answered. After this, we're going to have to officially close this webinar because we've already run out of time. It's been, as I said, a very packed 2 hours, very packed with information and insights. Thank you once again to all of the speakers present today, Pak Rendro Yoko, Pak Zainal, Dato Mohandas, Peter Jung, and Mr. Pillay. Thank you very much for making time. Feel free, for all panelists, feel free to stay on after we've officially closed this webinar to say hi to each other or say hi to some of the participants who might be staying on for 5 or 10 minutes. But we need to say goodbye for now. Thank you very much to the organizer, Indonesian Smart Grid Initiative. This event was also held jointly with PTPL and Persero. Sponsored by VSD Automation SDN Berhad Malaysia and supported by GSEF Global Smart Energy Federation and Masyarakat Energi Cerdas Indonesia or the Indonesian Smart Energy Association. Thank you very much for your time and see you at the next webinar.
Bye-bye.
Thank you, everyone. And thank you also to my co-host, Mr. Muhammad Reza.
Thank you, Mr. Reggie. Thank you, Pak Edi. Thank you, Putri.
Thank you. Bye-bye.
Thank you, Pak Ariatoyo.
Thank you, Mr.
Thank you, Pak Zainal.
Thank you. Bye-bye.
Thank you.
Thank you.
Bye-bye.
Exit.
Thank you, Dato Manas.
Yo,
Thank you.
Thank you,
exit
Mr.
ya.
Dato.
Leave meeting. Bye-bye.
Thank you.
Thank
Bye-bye.
you, Reggie.
Pak Dato.